Welcome back to my YouTube channel. Today I'm talking about the rlnorm function in R. Just like all the R functions we've been talking about that starts with R in a distribution, this generates random values from a probability distribution. Here we're talking about the log normal distribution. So this one's a little bit weird. The mean log and SD log are not the mean and standard deviation of the distribution we're generating, but rather the log mean and log standard deviation of the distribution we're generating. And I'll tell you what that means. Okay, so I'm going to start by making a vector x that's just going to hold the random values from the log normal distribution. So I'm going to go ahead and do 10 to the 6, so 1 million values from this distribution. The default value is a mean log equal to 0 and SD log equal to 1. I'm going to go ahead and make it different. So mean log is now equal to 10 and SD log will be equal to 5 or not. Okay, so now I have 1 million random values from the log normal distribution. Okay, so if I take the mean of this, it's not going to give me 10, it's going to give me some gigantic number, which is to be expected. But if I actually do, I'm going to do the pipe. I take the log of this, and take the mean of that, I get 10. Same thing with the standard deviation. The standard deviation is stupidly large. But if I actually do the log of that, I get the appropriate value of 5. So 1 second. It would help if I knew how to type. Okay. So I have the expected values of 10 and 5 out when I take the log of the distribution rather than the actual distribution. Let's go ahead and see what this looks like. Do a quick histogram. A lot centered around, actually it's a bit hard to tell where they're at if we have a very weird scale that goes from 0 to 10 to the 14th. Of course, that's really difficult to look at. How about quantile? That should tell us something. Okay, so we have values really close to 0, around 100, that'd be 10,000 of course, and then extremely large value, which is expected in the log normal distribution, of course. Okay, as in all of the random value generating distributions, I'm going to get a quantile. So let's say we want what percentage of these values are above 1 million. It's clearly there's going to be a certain proportion above 1 million, probably around 20%, but let's see. So I have a counter, which is going to count the number of values above 1 million. So for I in the length of x. So I have a for loop that I want I that count from 1 to the length of x, which is 1 million. So I need to make a condition if x of I is greater than or no, I won't even make it equal to. This is clearly a continuous distribution, and I don't need it equal to. It would be all the same, 1 million. Then counter equal counter plus 1. I run that. Now I want the proportion, so counter divided by the length of x. about 22% of the distribution is greater than 1 million. Okay, so that was like a quick way to get the proportion in the tail. Of course, we could do what proportions between two values if you just throw in an and. Okay, so that's the end of the video. Thank you for watching.